brackets minus 1.
1 minus r.
Yeah.
And this one?
Factorize that a, so you get 1 minus r, an a on the outside.
Yeah, a. That's 1 minus r.
And then you can cancel out the 1 minus r's, right?
That shouldn't happen. 1 minus r to the n. Hang on, did I do that wrong? Where's this thing on? ar to the n, sorry. That's dot 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 ar to the n. Yes, that's it. So that's r to the n. And so divide both sides by 1 minus r.
And you get a to the n on the right.
So just a to the 1 minus r to the n over 1 minus r.
Okay.
I don't think you can simplify it. And that's it. That's your formula for the sum to n terms. So we'll use it. Okay, how about this?
You know the equation what they give you on the data sheet?
I think they do. Let's see.
Like for all of the geometric, arithmetic, will they give it to you?
I'll just check.
Okay.
So that's year 1. Arithmetic they give. Geometric, yeah, there we go.
Yeah.
And maybe I'll just do that. But obviously you kind of have to know what you're looking at. It's geometric if it's multiplied by the same thing.
Yeah.
Each time. Okay, let's try it.
So could you sub in 2 for a then?
So a is 2.
And then you can make r 3.
R is 3.
And then you can make it to the power of n, right?
What is n?
10.
Yeah.
And then it's over 1 minus 3.
Yeah. And try putting that in your calculator.
Okay. $59,048.
59,048.
8.
Okay. B.
So you'd make it so a is 1,024.
So A is 1,024.
And then is r minus a half.
Minus a half.
And n is... we don't know what n is.
We don't know what n is. So how can we get n?
Do what we did before.
Geometric. What did we do before?
Or we did like ar plus ar squared plus ar cubed plus ar to the 4.
That was just to prove it.
Okay.
Let me see. So I'm thinking what we did with the sequences. AR to the n minus 1. Yeah. So let's say UN is equal to AR to the n minus 1. So let's say sub in the third term. I'll just pick the third term. So 256 is equal to A is 1024 times minus a half to the n minus 1. Yeah, so you just have to solve that. You could try put it. You could try putting it in calculator.
It says it can't solve.
Alright, we have to do it manually then.
Okay. So, suppose you can divide by 1024 on both sides.
Yep. So I think it's a quarter.
Yeah, I think so. Wait, let me check. Yes, quarter.
Alright.
And then you can use logs.
Yep.
So you do log minus a half. No, log like base minus a half.
Yep.
And then it's times by n minus 1.
I think it's to a quarter n minus 1.
And then you can plus 1 on both sides.
Yeah.
And then work it out from there to the calculator.
Alright, will that work though? Try putting that in calculator. Minus a half.
Okay.
Does it do it?
I'm working out now. It gives. Doesn't work because it's negative. The base.
What are we doing wrong here? B, so minus a half.
Would it be easier if we just multiplied at that stage by minus 1, so it gets rid of the minus half? Would you do that?
It just moves them negative, I think. So what they did was they wrote 2 as they wrote minus a half as minus 2 to the minus 1. Is that what they did? Hang on.
Oh, that works, doesn't it?
Minus 2. But then they just made it into minus 2 and minus 1. Ooh, they just made it positive.
Yeah.
So just use positive a half, see what happens.
Okay. That gives you 3.
Alright. Well, hold on. Wait. We know that we know that. We have to do all of that but with 1.
Okay. Wait, so where do we put 1?
So instead of where we used 256, so 1 is equal to AR to the n minus 1.
Yeah.
Okay, let's try this.
Divide by 1024 on both sides.
Yeah.
And then we can make it 1 plus log and then a half. You don't want it negative. The base is a half. And then multiply that by 1024, which gives you n minus 1. N, just n.
And that's 1 over 1024. So log, so base a half.
Yep.
24 and then plus 1. Alright, try that.
$11.
So n is 11. Okay, so use that up here.
You sub in 11 to 4 n.
Yep. So S11. 1024 times 1 minus minus a half to the 11 over 1 minus minus a half. I'll spare your calculator.
Okay.
Gives you 683. Alright, fair enough. Let me see this. Yeah, n was 11. Okay, great. So if we don't know n, but we know the last term, we have to sub it in to find n.
Yeah.
Let's see this one. Alright. Hang on. Before we do weird stuff. Alright. No, it's getting weird. How about this?
Okay. So for this, would we do we need to use the equation we used before to work out what?
Yeah. I'll just copy.
Which is like UN equals.
Let's see. The value of n such that the sum to it exceeds that. I don't think so. It might just be this is greater than 2 million.
Okay. So if we just worked it out. So make A1R multiplied by 2.
Yep.
Well, then n is 2 million.
Well, no. They have to add
It's
up.
2 million, not 10. Oh, okay.
They'd have to add up to 2 million. So, then.
Okay. So for the top, it'd just be 1 minus 2 to the power of n. And then the bottom's 1 minus 2.
That's 2 to the n over 1 minus 2. And that has to be greater than 2 million.
Yeah.
That's how it works. All right. What's next?
Can we simplify the bottom?
Yep.
It gives you minus 1.
Yep. What's next?
And then do you want to get rid of the 2 million on the right? Oh no, you can get rid of the minus 1. Right?
Okay. Yeah.
Times by minus 1, so it gives you minus 2 million on the right.
So that's minus 2 million. What's on the left?
1 minus 2n.
What's in the middle?
Great. It's greater than minus 2 million.
It's now less than because you multiplied by a negative.
Okay.
So watch out for that. That's why they use these a lot for this.
Okay.
To check if students will do that. Okay, go on.
Yep. Now can you minus 1 on both sides?
Yep.
Which gives you 1.999999.
Sure. Let's do minus 1.
And then you can multiply by minus 1 on both sides.
Yep.
Which gives 2n is lesser than. Or would it flip again?
Yeah.
This 2n is greater than positive 1,999,999.
And that was negative and we subtracted 1. So wouldn't it be...
Oh, so it adds 1.
Yeah, I think
2
so.
million and 1.
Yep.
And then we can use logs now.
Yep.
So we just do log base 2
Yep.
multiplied by 2 million and 1. Or just 2 million and 1 on the right, on that side, yeah, and the equals n.
Yeah. Let's see what calculator says.
20.933.
And so first term that will exceed, where the sum will exceed 2 million?
The first time that it exceeds 2 million is 21.
Yeah. So 21st term.
Yep.
Let's see. Yeah, it needs 21 terms to exceed it. Great. So it's just that formula is greater than 2 million.
Yeah.
Okay. It's now getting weird, is it? We'll see. Alright, how about this?
Okay. Is common ratio just n, right?
Common ratios are.
Okay. So we make A10 and R3/5.
Mm-hmm.
And then we make N10.
Yep. Wait, A is 10 as well, is it? Yep.
Oh yeah, they're both 10.
Hang on. There's a mixture here. They want the 10th term, not the sum to 10 terms.
So we make it equal to 10.
For this one, it is the other formula. Do you remember it? The sequence formula.
It's A brackets.
No.
That's AR to the power of n minus 1.
Yeah. And so U10.
So you make N10, right?
Yeah.
A10 times 3/5 to the power of 10 minus 1.
That's it. And you get your answer. How about B?
Okay. So for this, do you want to use Sn equals A brackets 1 minus R to the power of n over 1 minus R?
Yeah.
And we want n, so do we make it? We still use A is 10 and the common ratio, which is 3/5, which is R.
Yeah.
And we want to make it equal to, is greater than 20. So 20 on the right, and that's greater than it.
Yes. And so what are you subbing in?
10 brackets 1 minus 3/5 to the power of n over 1 minus 3/5 is greater than 10. Oh no, greater than 20.
That's it. Alright, let's try this.
Okay. So you can simplify the bottom first.
Mm-hmm.
It's 2/5.
That's 2/5. Nexty.
And then could you do 1 minus 3/5 again on the top?
No, because of bidmas, you have to do the power first, and we don't know the power.
Okay. So could you you could minus 2/5 on both sides, multiply by 2/5 on both sides.
Yeah.
Which gives you 8.
So that gives you 8. So 10 times 1 minus 3/5 to the n is greater than 8.
Then could you multiply 10 in the brackets?
Yeah.
Expand the bracket.
The problem is you're not gonna. The first bit will be okay, but the second bit you'll still just have 10 times 3/5 to the n because of bidmas. You could divide both sides by 10.
Okay, so it's 8/10.
Yeah.
Or simplified to 4/5.
All good.
Okay. So now you have 1 minus 3 over 5 to the power of n. And then you can just plus n on both, minus 1 on both sides.
Yeah.
And you get minus 1 over 5 on the right.
So
And
that's
then you can multiply by positive 1 on both sides.
negative
Oh,
1
minus
above.
1, sorry.
So that
Yeah.
was, so let's say it was 0.2 or something. Oh, let's see, yeah, it's 1 over 5, isn't it?
Minus that 1 over 5. And then if you multiply it by minus 1, it flips the thingy, right?
Yeah. Oh, yeah, I forgot. It's going to flip that. All right.
And then you can use logs.
Yep.
So it'd be log base 1/5.
No.
Oh, it's 2 over 5 then.
Yeah.
And then it's in the brackets, which is 1 over 5. Is equal to. Well, it's not. It's equal to n. So
We'll do equal to.
that gives you. That's equal to 3.15.
3.15. And so,
The least value and that needs to be greater than 20 is 4.
will it be 3? Because it's less than? It has to be less than that. Let's see. That's 4. All right. There you go. Grant. I think you're good. Just that something has to be greater than 20, and then you just go through the process of solving. It's not too bad. This one, they mixed in the previous one. It's not the 10th term of the series. Oh, maybe I'm wrong. I am wrong. Series means what you get when you add them up, not sequence.
Okay.
So the 10th term of the series to 3 decimal places. No. Yeah, we're right. So we said it was like,
Okay.
I forgot. Oh, we didn't actually get it. Okay, we're right. It's a series. We just found the 10th term. All right. This looks exactly the same. It's got a ln. They just solved it a different way by taking ln of both sides. Hang on. First term 20. Con ratio k terms is greater than 50. No, we'd better wait. No, that's fine. It's exactly the same.
Yeah.
Let's see. Very, very similar. Alright, this looks good. No, this belongs in the previous section. Nah, well, it's a bit of... Alright, how would you do it?
So for this, you've got A is 2k minus 4.
Yep.
And then we can do k plus 2 divided by 2k minus 4 and k minus 1 over k plus 2.
And what about those?
Those give you the...
What goes in the middle?
It's the right is greater than.
These are equal because they're both
equal to each other.
They're both equal to the common ratio.
And then you solve it.
Then-
Solve for k.
Then you solve it. Then you have k. You get k is 10. So how could you use that to do part C?
So the first 20 terms, you'd have to make you still have to make a 2k minus 1, but you can minus 4, but you can sub in 10 instead. Okay.
Yeah.
That's 8.
So what is 8?
A is 16.
Yeah. So that's 16. That's 12. That's 9. How would you do? Yeah. How do you use that for C?
we want to work out the common difference.
Common ratio, yeah.
Common ratio. So you can do that by making it S20, right?
So we have to do S20.
Equals. Wait, so it wouldn't be S and then N would become 20. Equals 16 brackets 1 minus R to the power of 20.
What is R?
R is a common ratio.
Yep. What's the common ratio?
Quarter.
12 over 16, basically?
Ah.
Or 9 over 12? What is that?
Wait, is 16 over 12?
Other way around. Like 16 times R gives you a 12 over 16. It's basically you sub it into one of these up here.
Okay. 3 over 4. 3/4.
That's it. So let's do 0.75 to the power of 20 over
1 minus 0.75.
1 minus 0.75, and then you just put it on the calculator.
Yeah.
Let's see. So for this one, we had to use that thing we did previously. How, like, they're both equal to the common ratio. They must both be equal to each other. It's like second takeaway first and third takeaway second for common difference.
Yeah.
That gives us K, which we can use to find R. And then we have everything we need for the third part.
Yep.
Let's see. Geometric series. All right. I think there's something to this. How do we do this?
Okay. So for this, you want to use the other equation, right? Which is UN equals AR to the power of N minus 1.
Now, that would be if it was the second term is this and the fourth term is this. The sum to two terms.
Oh,
This is the sum formula.
so would you make it like SN or 1 plus 2? Right.
This one would be S2. Sum to two terms.
Just S2. Okay. Equals A. We don't know what A is.
Mm-hmm.
And then 1 minus R to the power of 4.48.
No. What is N?
Oh, 2.
Yeah.
Is equal to 4.48.
What's the denominator?
S4 equals
Hold on.
A.
Hold on. What's the denominator?
On the bottom. 1 minus R.
Yeah. Okay. S4.
S4 equals A brackets 1 minus R squared. Not squared. R to the power of 4.
Yeah.
Over 1 minus R, which equals 5.1968.
All right. What are we doing here?
Can we expand the bracket at the top?
Let's see. Let's get rid of the denominator first.
So you can multiply by minus 1 minus R, which gives you 4.48 minus R.
Yeah. Let's see. So 4.48. I'll leave it as times 1 minus R.
Okay.
Let's see. So let's make this A equals.
Okay. Would we? Do we have to expand the bracket with A, or do we not have to?
No. So make A the subject. How would you get A by itself?
Divide by 1 minus r squared.
So 4.48 times 1 minus r over 1 minus r squared. So that's A. How can we use that?
Could we sub that back into the equation?
Yeah.
I said.
Yeah, sub it into the other equation. So instead of A, we would have 4.48 times 1 minus r over 1 minus r squared. And that's times... hang on. This other equation... Yeah. 1 minus r to the 4... and that's 1 minus r.
Yeah.
And that's equal to 5.1968. Okay.
Yeah.
And so you have to solve it. Alright, let's try it.
Okay.
How do you go about this one?
So for the right, would you want to multiply the fractions first, or could you just cancel out and simplify first?
Let's I think get rid of the fraction first. That's the bit that scares me.
So could the fraction on the right get simplified to 1 minus r cubed? Does it work like that?
No, it doesn't work like that. Let me see. Alright. See, I don't wanna do tricks. There are little tricks, but 1 minus r squared. 1 minus r. That's what I'd do. And now just fully expand, fully simplify. That expanding, hang on. Well, it's not the worst. Expand the brackets first.
Okay. So you get 1 and then plus r cubed on the right.
On the right side, is it? Yeah. You'll have two things in the middle as well.
Oh yeah, and on the left, what would you wait?
So you have 1 at the end. You'll have plus r cubed. And in the middle,
You'd have minus r squared, and then minus r squared again.
minus r.
That's minus r. Okay. Oh yeah. 'Cause it's on,
All right, left side.
it'll become 1 plus r to the 5, and then minus r and minus r to the 4.
Hold on.
And then you can simplify, right?
How?
Oh no, you can't. I don't think you can.
I'd expand.
So you get 4.48 minus 4.48 r minus 4.48 r to the 4 plus 4.48 r to the 5.
Yeah, hold on. That's gonna annoy me. Let's just divide both sides by 4.48. So what is that number divided by 4.48?
Sure. It's 1.16.
1.16. Okay, so 1.16. So we do that to this side. What's next?
And then could we -1 on both sides.
Yep. So that'll be 0.06.
Yeah,
0.16.
0.16. Yeah.
Alright, what's next?
And then could we divide by -r on both sides?
Make it equal to 0.
So can we just add r to the 4 and -r to the 5 on both sides?
Yeah. So if we add 1r, that's 0.16r.
Yep.
We don't have an r to the 4 over here. So we do now. And we don't have an r to the 5. Okay.
Yeah, just -r to the 5.
And then everything else stays the same. Alright, how do we solve this?
Okay.
Here's how I'm solving it. Oh gosh, please let this be in the calculator. Probably doesn't, does it?
No, I don't think this is a 5. It goes to quartic and that's the maximum, I think.
They could have made it go to the 6 and they chose not to. That's terrible. Terrible bookie. Alright, little thing that we could have done is 1 minus r squared is the same as, it's like difference of two squares. So 1 minus r, 1 plus r. 1 minus r, so that's 1 plus r. 1 minus r.
Yeah.
Hang on. On the other side you have 1 minus r, 1 plus r, and it gets rid of that. Okay. So yeah, difference of two squares. 1 minus r, 1 plus r. And so 4.48 times 1 minus r to the 4 is equal to 5.1968. Let me see, what got that got, that's 1 minus r, and this one is 1 plus r.
Yeah.
And then you just go from there. You're only going to have r to the 4, and so you do the same stuff. Hey, come on, Bookie, what are you doing to me? Give me these questions. Let's see. They did it the same way with this stuff. Yeah, 1.16 using their little tricks. Alright. Let's see. Yeah, better do it.
Okay. So to use S2 equals.
It's not the sum to two terms, it's the second term. So it's U2.
Oh, so U2 equals AR to the power of 2 minus 1 is equal to 96.
And 2 minus 1 is just 1. So AR is 96. Yep. What is next?
And then do we need to solve for A with AR plus AR, A plus AR plus AR squared equals 292.8?
You could try. What could you do?
So could you would you want to get rid of the square first of R?
Well, you see the AR. What could you
Yeah.
what could you replace that with?
Oh, the AR and the 96.
So A plus 96 plus AR squared equals that.
And then we can minus 96 on both sides.
Yep.
Which gives you 196.8.
So we've got two unknowns there, A and R. Let's see. So this is sum to three terms.
Yeah.
So the sum to three terms is 292.8. What else can we do?
The sum to two terms.
I think we can use our formula. I don't know if it's any good though.
Okay.
So A to the 1 minus R. What is N?
N is 10. 3, sorry.
3.
So it's 2 to the power of 2.
It's not N minus 1, it's just N.
Oh, okay.
Okay, so is that two different equations for the same thing?
Well, what do you mean by that?
Like it might just be. So this is 292.8. This is 292.8. So they're both equal to the same
Oh,
thing.
right. Oh, could you make them equal to each other then?
So I'm just let me see. A plus 96 plus AR squared. A 1 minus R cubed over 1 minus R. Is this a second equation or is it just the same thing? So that has two unknowns. Let's see. Oh, I don't have the working out. I just don't want to start down a simultaneous equations thing and find out that they're identical instead of
Yeah.
similar. Let's see. So A times R is 96. Wait. So that's definite. That's a different equation. That's a different equation.
Yeah. It's different.
And so, but we already kind of subbed it in. Well, let's say A is 96 over R.
Yeah.
Is that what we want to? Is that going to be easier? All right. A is 96 over R. So everywhere I
You can
have
sub that in for A. Yeah.
96 over R.
That means there's only one unknown, which makes it easier, right?
Well, it means we can solve it.
Yep.
1 minus R. If we have two unknowns, you can't.
Yeah.
All right, and then you just solve that thing. Let me see. There's a common ratio. Hang on. I just want to see what happens if I put this whole thing into my calculator.
Okay.
It's 96 plus. Yeah. You could just put this whole thing in calculator.
Okay.
And 96.
You forgot the R squared, isn't it, on the left, and the R.
They
divided by R.
they cancel.
Oh, they cancel out. Oh, yeah. Okay.
One of them cancels.
Yeah.
1 minus X. I just didn't want to have to do a fraction. Hopefully I've put that in right. Shift, solve, lucky 7. Oh, is it 7? Oh, great. Hang on. So shift, solve, unlucky 6. Wait. I think it might be identical.
Yeah. It gives the same number.
Oh, what are we doing wrong here? Okay, the second term is 96. So AR is 96. The sum to 3 terms. So is that first term is A. I wonder if you do U3. U3. That's not really helpful, is it? There's three unknowns. That's what's happening here. We need a third equation.
Okay.
What are we missing? The sum to 3 terms. So this one is as good as any. So AR equals 96. I think that's all we need. And A plus AR squared equals 196.8. I think those two equations are all we need.
Yeah.
Okay, so we said what was easier to sub, and we said A is 96 over R. So if we sub that in, plus 90. All right, 96 over R, yeah, plus 96R equals that. And how do you solve that?
Then we can solve for R. Divide by 96 on both sides.
It's a bold strategy. Okay. What is this one divided by 96?
Uh, 20 over 41. Wait, did you say 96 divided by 196.8?
No, you said so what was it, 41 over 96, 41 over 20, is it?
I think so. Yeah, 41 over 20.
Alright, how do we solve this?
Could we minus R on both sides and multiply by R?
Yep, times everything by R.
And that gives you 41 over 20 R, and then 1 plus R squared.
So, yeah, 1 plus R squared, and let's say minus 2.05 R equals 0.
Yep. And then you can just solve it as a quadratic by simplifying the 1.
Why you love simplifying stuff? Just calculator.
Put it in the calculator.
I would have done that even without dividing anything. Yeah, I was just overcomplicating it. So it's either 1 1/4. It's either 5 over 4 or 4 over 5. R is equal to 5 over 4. That's weird. And then you find this sum to 10 terms. Then you just sub it back in. Get A.
Yeah.
And then sub it A, R, and N is 10 into the thing. Are you able to stay longer? Because your thing didn't start? Alright.
Yeah.
Let's see this one. Show that as 10. I just want to see if there's something, make sure I'm not missing something. So the first term of a sequence is A, common ratio is that. That's alright. They're using square roots, surds, but it's the same idea.
Yeah.
Okay, this looks good. How about A?
So for this we need S2, right? But it's equal to S3.
I believe it's equal to U3, is it?
Okay. Then do we write out the equations from that? So we have S2 equals, and then A 1 minus R N, and then over 1 minus R.
Yeah.
And then for U
Hang
it's
on.
AR,
Hold on. What is N?
and is 2 for the left.
Yeah. Okay. Right side.
And that's over. And then the right side is U3
Mm-hmm.
equals U3 equals AR to the power of 3 minus 1, which is 2.
And how can you simplify?
You want to get rid of the fraction first.
So they wanted us to show that this is independent of A. And
So do we just want A then?
you want to get rid of A.
So you could divide by A.
Yeah.
Both sides, which cancels them out.
Yeah. And so 1 minus R squared over 1 minus R is equal to R squared, therefore it's independent of A.
Yeah.
So it doesn't matter what the first term is. Given further that the common ratio is positive, the first term, so A is 2. A is 2. Let's see. You just solve for R. Alright, let's solve for
R. Okay. You'd make it S20 now.
No, solve this equation.
Okay. So we can multiply by 1 on both sides, then multiply by minus R.
You have to keep them together. Multiply by 1 minus R.
That'd give you minus R squared and then plus R cubed. Right?
Just
on the right.
Just what's on the left, what's on the right?
On the left it'd be 1 minus R equals R squared brackets 1 minus R.
Yeah, there you go. Just keep it simple. And now expand.
R squared minus R cubed.
There you go. So it's not plus, it's just not double negative. Next.
You can add R squared to both sides, so it's 2R squared.
Yeah.
Equal minus R cubed equals 1.
And then
you can just minus 1 on both sides to make it 0.
Yeah. And then
you can just put it into the calculator.
Alright. Let's see. Finally it's a 3. Oh, there you go. And they said, what is this? They said the common ratio is positive.
Yeah.
So we get 3 answers. One of them is negative.
Yeah.
One of them is
1.6.
One of them is 1, which it can't be, because then it would just be the same thing over and over. So this one here, 1.618. This looks very familiar.
Yeah.
I wish I could copy that number somehow.
Yeah.
How do you do that? Store, is it? Store that number to A or something? Store it to A. Let me go back. Alpha A.
Yep.
Answer. I was trying to get it as a fraction. Alright. So then we have R, and then we do, hang on. And they gave us A, They want sum to 20 terms, so n is 20, and we sub all three into sum to 20 terms.
Okay.
Okay, grand. Let's see. So they like this. They like these. First term A, common ratio 2. A different geometric series is first term B, common ratio 3. Given that the sum of the first four terms of both series is the same, show that that's that. That seems not too bad. I think we're okay there.
Yeah.
Let's see. I think we got the best of it. Yeah, so geometric series, what do you give yourself?
Probably between 6.5.
So, let me just see something. Sum to infinity. So there's a bit of sum to infinity, but it seems like that there's lots of exam questions for that stuff. How was that for you, Adam?
That was great.
And so continue this next time?
Yep.
Alright, any questions for you in general?
Nope.
Alright, well done. You did great, and have a good
Thank
weekend. You
Me
watch?
too.
Do you watch this football?
No,
Alright, me neither.
I don't.
I only heard about it. Alright, take care.
See you later.
Bye bye.
Bye.